Hey guys, so in this video, we're going to review properties of logarithms, and I'm just going to get right to it. So I'm assuming that you've seen this once before. If you are looking for like a slower, more complete breakdown, I do have a series on that, but I am just going to like go straight through it, assuming that you have seen this at least once before, but maybe forgot. Okay, so we have a bunch of different properties. You just have to have like all the standard things with logarithms true. So x, y, a all greater than 0, a can't be 1. And then we'll eventually have an r. R is going to stand for a real number. Okay, so the product property. Log of a times xy. So look at what this does. You're multiplying x and y. You can break this up into two separate logarithms, log base a of x plus log base a of y. Quotient property. So I have log base a of x over y. So check out what you can do. You can subtract x minus y. Log base a of x minus log base a of y. Okay, so that's the first two. Let's move on to the next two. Next, we have the power property. So notice what happens here. I've got log base a of x to the r. So notice what happens. I bring the r down in front of the logarithm, and then it's just log base a of x. So you can move it down. Boop. We have log base a of 1 equals 0. So this actually makes a lot of sense if you think about the exponential definition. So if I just write the exponential equivalent of this, this would be a to the 0 equals 1. So we know that anything to the 0 power equals 1. So okay, that makes sense. Same thing can be said for this next property. Log base a of a equals 1. So again, if I just write this out in its exponential form, this would be a to the 1 equals a. So okay, that makes sense. The last two properties that I want to show you are, so this actually has to do with the composition of inverses. So remember, a to the x and log base a of x are inverses. So in another video I discussed this. So a to the x and log base x, they are inverses. So if I were to compose them together, so a to the log base a of x, if you know about the composition of inverses, then this should equal x, and vice versa. Log base a of a to the x equals x. So these look like properties. This is actually a property of composition with inverses, so not totally surprising. The other thing I want to mention, I want to review, these aren't properties, but these are just helpful things to remember. So log of x on your calculator always means, for every single calculator in the entire world, it means log base 10 of x. This is just a really common logarithm, and so we don't feel the need to write base 10. And then also the natural log of x, this means the same thing on every single calculator in the world. It means log base e of x. Again, these are just two really common logarithms that we just write them like this, and we just know what we mean. So if you see log of x, it doesn't mean log base 2. It doesn't mean log base anything else. It always means log base 10. Okay, so what we're going to do is we're going to play around with the properties a little bit just to refresh your memory. So we want to expand these as far as possible. And I want to give you a little trick about like a thing to remember with the properties. Okay, so everything on top gets a plus sign. Everything on the bottom gets a minus sign. This is when you're trying to expand logarithm properties, this always works like this. So if I'm trying to expand this expression using the properties I previously talked about, so notice all the stuff on top is being multiplied together and then it's being divided by this square root of z. So you can just like write this out. Log base 3 of 3 plus log base 3 of x cubed plus log base y, log base 3 of y to the 7th minus log base 3 of the square root of z. Okay, so look at what I did. All the stuff that was on top, it's all positive. You can just bank on that. Boom, nothing to think about with it. Anything that's in bottom, so if I had multiple variables in the bottom, they would all get a minus sign. So breaking this expression up like this, I can do more, right? So first of all, I've got log base 3 of 3. So going back to one of those properties we were talking about, log base a of a. So I know right away that log base 3 of 3 is just going to equal 1. So this is equal to 1. And then for these other terms, I can bring down the exponents. So this will be plus 3 log base 3, having trouble writing little 3's, log base 3 of x, plus 7 log base 3 of y. And then what's the exponent associated with the square root? that would be the same as 1/2. So minus 1/2 log base 3 of z. So this is a really big thing. I think this is like a thing that throws a lot of people off of like, oh, how do I break this up with all these different variables on top and on bottom? It's actually very simple. Anything on top gets a plus sign, anything in the bottom gets a minus sign. So we'll play around with that a little bit more. Okay, so I want to challenge you to try this one on your own. Just play around with the logarithmic properties now that we've done one together. Remember, math is not a spectator sport. So if you're trying to review this, you're going to get more out of it if you try it on your own and then hit play when you're ready. Okay, so I think this is a little tricky just because we've got the 1/3 or the cube root. So I can rewrite the cube root as 1/3 natural log of x squared y. So I just took this cube root over everything. Here's what you have to be careful about. This cube root applies to both of these. So if I want to break this logarithm up a little bit more, I need to put a bracket around this. So I can break this up as the natural log of x squared plus the natural log of y. But notice how the 1/3 is going to be multiplied into the whole thing. And then finally, I can write this as 1/3 2 times the natural log of x plus the natural log of y. And then if you want to, you can distribute that 1/3 in, tomato, tomato. I'm going to write this as 2/3 natural log of x plus 1/3 natural log of y. That is truly as expanded as I can possibly get this. So let's talk about c, because this one I think is actually deceptively tricky. Okay, so you're probably thinking to yourself, oh, it's just 6. So and it's the square root of 6. So I can bring down the 1/2 exponent. But, my friends, we can break up the 6, right? So 6 is equal to 2 times 3. And this actually matters in this problem, because if I break this up into log base 3 of 3 plus log base 3 of 2, there's another simplification that happens in here, right? Namely, this, we know, goes to 1. So I have 1/2 times 1 plus log base 3 of 2, and that's going to equal 1/2 plus 1/2 log base 3 of 2. Okay, so considering what we just did in part C and what we did in the first problem, I want you to try this one entirely on your own. And once again, hit play when you're ready. Math is not a spectator sport. You will definitely get the most out of this if you try this on your own. Okay, so remember, everything on top gets a plus sign, everything in the bottom gets a minus sign. I can just go ahead and bank on that. So this is going to be log base 5 of 25 plus log base 5 of x cubed plus log base 5 of y squared minus log base 5 of p to the 7th minus log base 5 of r to the 3rd. All right, so there's a lot I can unpack here, and then I've got to get a little creative with some of this. So I want to think of 25. I feel like there's something I can do here, right? So the thing I notice is that 25 is equal to 5 squared. So I'm going to rewrite this then as, actually, let me just rewrite it like that. So instead of writing this as 25, I'm going to rewrite this as 5 squared, because now I can move on to the part, right, where I bring all these exponents down. So let's go ahead and do that. So this becomes 2 log base 5 of 5 plus 3 log base 5 of x plus 2 log base 5 of y minus 7 log base 5 of p minus 3 log base 5 of r. And then this part here, let's see if I can grab a different color. So, oh, I'm having trouble with my pen, sorry. Okay, there. This goes to 1, right? So I'm running out of space here, so I'm just going to rewrite this. So this becomes 2 times 1. So I'm just going to rewrite this whole little part here as just 2, right? And so there is your final answer. So, okay, cool. So we've expanded. Of course, now we want to go the other direction, right, where we write as a single logarithm. All right, so the thing I told you about plus signs mean the term goes in the top versus minus signs means the bottom, that still works here. So looking at this first example, so I've got log, this is positive, positive. So this will be x plus 2 times x minus 2, and then the denominator you get x plus 3. And if you can easily multiply everything together, I would recommend doing so. This will just be x squared minus 4 over x plus 3. Bada bing, bada boom. Okay, so what about this expression here? So you might start to get a little faster with these, and you might start to notice, oh, this is just 3 cubed and this is just y squared. You can play around, like I'm always going to show you the longer path to get there just in case anybody needs to see it. But I would recommend just trying to think for a second, trying this one on your own, hitting play when you're ready. You can do this in like shorter steps if you're starting to get used to it. If not, just take the longer route. Hit play when you're ready. Okay, so I just want to do this in steps here. So this is going to be log base 2 of 3 to the third, and then log base 2 of y squared minus log base 2 of x to the fifth. So I've just rewritten all of these with their powers. And then I can rewrite this as log base 2. So 3 to the third is 27. The y squared goes on top, and then the x fifth goes to the bottom. And that's a terrible looking 5. X to the fifth. Okay. Okay, so these had positive signs. They went on top. This had a negative, so it went in the bottom. 3 cubed I can easily evaluate, so I did. The other thing I want to point out, notice this is a single logarithm, log base 2 of all of this stuff. Okay, so I've got another one here for you. So I would recommend, again, give this a try, hit play when you're ready. Okay, so I'm going to rewrite all of this. Log base 5 of 16 to the 1/2. So this gets a little trickier here. So I've got log base 5 of y squared. So it's y squared to the third. So you need to put a set of parentheses around this, okay? And then I have this other stuff, minus log base 5 of x to the 7th minus log base 5 of y. Okay, so let's evaluate what we can. This is going to be, let's see, actually let's put stuff on the top now. So I've got log base 5. So, okay, 16 to the 1/2, that's the square root of 16, so that's just going to equal 4. Then, y squared cubed. So I multiply these exponents together to get y to the 6th. So that's what goes on top. What goes in bottom? X to the 7th and y. And now you notice, right, you can actually simplify this farther. So I can reduce the y's so that this becomes log base 5 4y to the 5th over x to the 7th. So this y cancels out and I can just subtract 1 from the exponent. Now maybe you're saying, hey, I noticed that at this step and I just did the subtraction earlier. Tomato, tomato, you could either have reduce the y's at this step, or you could have done them after you put everything together. Doesn't matter, you still get to the same answer. Okay, so I've got just one more here for you, kind of putting everything together one more time. I'd say pause the video, give it a try, hit play when you're ready. Okay, so first I'm just going to rewrite everything with the exponents. So I've got kind of the same deal as before, x squared cubed. Okay, so now if I rewrite all of this, so I have the natural log, so 2 to the 4th is 16, this is x to the 6th over, okay, y cubed squared, this will become y to the 6th, and then x squared cubed, this will become x to the 6th, and then you'll notice you can cancel out the x's, right? So this actually just simplifies to the natural log of 16 over y to the 6th. Again, tomato, tomato. If you noticed that you could get rid of the x's in this step, like in the previous steps, also totally fine. You would have gotten the same answer. So some of these have a little creativity and there's more than one way to get to the answer. All right, and so that brings us to the end of this video. Logarithmic properties, they are pretty important. They're easy to forget. They're very easy to forget. So I recommend just having them if you're moving on to like a class like calculus, have a place where you can easily pull these back up in the future because they come up a lot in calculus. That's why we talk about them in pre-calculus. Okay, so that brings us to the end of this video. I will talk to you guys next time.